Hi everyone, we just wanted to put together a video to show how some of the common controllers in the ShotoLab software work. Today we're going to demonstrate how the PID controller works, a set point controller, as well as the percent controller. To do this, we're going to use these three different flasks with typical heating mantles. These flasks are filled about 3/4 full with water. I'm going to put a thermocouple between the mantle and the flask for each of these, as well as a thermocouple in the liquid for each of these to monitor the temperature. If you want to know how to make these thermocouples, just go to our thermocouple video. It's very simple and easy. All you need is a piece of thermocouple wire. And these thermocouples will serve as temperature inputs for the ShotoLab software. Once everything is set up, plug in the heating mantles. These are typical glass cold mantles. We're going to plug them into our ShotoLab system. So once everything's plugged in, we're ready to proceed. Before we show the software, I just want to show you the configuration of the ShotoLab boards and power supply. Here you can see 6 different thermocouple wires attached to this terminal strip. This is on the TC board, the middle board. On the lower terminal strip, I'm just using a Cat5 cable. It's got a whole bunch of different wires on it. Makes it look a little complicated. But actually, this is a setup that I just keep set up all the time. It allows me to use the ShotoLab power supply with 3 different heating mantles or other 120 volt products. This might look a little complicated, but the simple fact is when you use 3 different controllers, you have to have 3 different wires and 3 different setups. So it's just the nature of the beast. But again, I just keep this set up in my hood all the time. Once everything is connected, turn on the software. I'm going to enter in some typical data, the experiment name, the number, who it's conducted by, what's the purpose, and a simple description of the setup. All of this information is stored in the computer if you save the file. Once it's all typed in, go to the channel setup page. Now we have to name all of the thermocouples we're using. We have one in the 250 mil mantle and one in the liquid, the 500 mil mantle and the 100 mil mantle. And I work top to bottom because it's just quicker and easier. After that, we have to configure the type of channel. These are thermocouples, so name them all type K thermocouples. After that, activate the channel by pushing the button. And once that's done, you can see the units automatically come up. The decimal point, 1 decimal point unit is going to be shown on the display page. The temperatures are all shown. So now let's go to the control output page. Again, first thing to do is name what these outputs are going to do. The first one will use a PID. The second one will be the percent controller. And the third one will be the set point controller. Then you have to configure the channel. To do this, click on the wrench. Now we have to select which thermocouple is going to be used to control the PID. The first channel is on the 250 mil mantle, so we're going to use the liquid to control this PID. So select the 250 mil liquid. We're going to change the P to 8 and the I to 6. Normally I use 8 and 10. This is going to go a little faster. There's going to be a little more overshoot, but this will just show you how it works. The next one is a percent controller. You can keep everything as the default settings. The percent controller works like a typical variac. 0 is 0 heat, 100 is 100% heat, 50 is 50% heat. So you can keep all these set points at the default. The next thing we're going to configure is the set point controller. Just like the PID, you have to select the reference channel that is going to be used to control this controller. The next window has a comparison. This will tell the system to go on if the value is less than what the set point is. That works perfectly for heat. Once that's set, hit OK. I like to click the display status boxes. This puts the indicators on the display page. And again, after that's done, just activate the channels by pushing the button. Now let's go to the display page and enter some values. Let's put 50 for the PID, 25 for the percent, and 70 for the set point controller. Let's auto scale this to see everything. Let's save the data. Let's just set it to controllers. And you can see everything is working. We have the set points shown here. You can see the mantle temperatures are going up. Things are working well. Let's just show some other plots that we can do. Here we're going to do all the temperatures. On the main screen, there's a bunch of other data plotted for, it's beneficial. I just like to keep it. And I just like to set up other plots. We have 6 options we can do. The first one, we're going to show all the temperatures. The second plot, we're going to just show the heating mantles. The final plot, the third plot, let's just do the liquid temperatures. Let's just move that to the bottom left corner. Let's just position this so we can still see the set points. Let's move all the temperatures. Let's put it up on top. A main one. Let's move it to the left a little bit. Cover that up. Let's put the mantle temperatures on the bottom left. Just try and position them so we can see what's going on. These are the indicator lights. They correspond to the indicator lights on the power supplies. You can't see them, but they show when things are actually heating up. You see from the plots, everything's going up. Things are looking good. Let's talk about this set point controller. It's set at 70, and this is on the heating mantle. And you can see this is getting close to 70. It's currently at 64.5. As soon as this temperature gets above 70, this light is going to go off. Remember, when the temperature is less than the set point, the unit is on. So it's above 70 now, and the light is off. Let's auto scale all these plots to see everything. The 500 mil has a percent controller. You can see it's set at 25. This light then will be on 25% of the time. Now everything's still working. PID temperature is going up, and that'll go up until it gets to 50 degrees. And you can see the time here. It's about 3 minutes in. It's 169 seconds, about 3 minutes in. Okay, the set point controller fell below 70, and you saw the light came back on. It's above 70 now, so the light's off. And you can see now how this is fluctuating around 70 degrees. There's a little bit of an overshoot here, which is causing the oscillations. So let's just let this run. I'm going to speed it up. I don't want to waste all your time on this. If you want to look at something in more detail, you can slow it down or pause it. But you can see the PID now is activating. It's getting close to 50, so the mantle temperature is going down, the black lines. Let's change the temperatures to 70 and on the PID. You can see it's going back up. Okay, so I changed the values. I changed the PID to 70, the percent controller to 50, and the set point to 100. And again, you can see everything is going up. You can see the PID, it overshot a little bit. Now it's undershooting a little bit. And again, this is because of the aggressive nature of how I had it set, with the I value being at just 6. You can watch our video on the PID controller to see how it works in more detail. But it does level off to 70, as you can see. Let's change things again. The PID is at 90 now. Again, you see it going up. And from the screen here, you can see how everything else is working. The set point is oscillating at about 100 degrees. This is the mantle temperature. The liquid is quite a bit under that. Let's change the percent controller to 75. Again, you see that going up. Now remember, 75 is like 75% heat, just as if you were to turn a variac to 75. You see the mantle temperature going up, and you see the liquid heating up at a faster rate. That's a brief video to show how you can control 3 different reactions with 3 different mantles using 3 different controllers. I hope you enjoyed it, and I hope you enjoy using our ShotoLab system.